I'm going to go over the study guide. So, physical properties, this is matter that can be observed or measured without changing that matter's identity. Stuff by like density, looking at the color, if it's shiny, we call that luster, all that kind of stuff. I think there's more examples down here. Maybe not. There it is, right here. Number 11 has more examples. Physical change is when you have the change where it looks kind of different but doesn't actually change chemically. So like if I were to crumple up a piece of paper or rip paper or something like that, that would be a physical change. Melting butter, melting water, melting even metal would be a physical change. Chemical property is based upon that ability to change. And again, I think it's number, somewhere in here. You'll have some examples. So chemical properties, can it catch on fire? Can it react to something? Is it going to be toxic? Is it acidic? Is it corrosive? So is it going to like cause metal to break down? Does it react to oxygen? All of that kind of stuff. So with the chemical property, it's almost impossible to determine if it is a chemical property unless it actually goes through that chemical change. All right, chemical change, you have one or more things that become one or more different things. Cannot be returned to its original form. A very common example would be like baking a cake. You cannot reverse it and turn it into cake batter. Unlike ice, I can melt ice and refreeze it and melt it and refreeze it. That would be a physical change. Law of conservation of mass can't be created or destroyed. We are not God, so we cannot create anything like that. Types of reactions, the first one is your synthesis. This is when multiple things combine to become one single product. So here you can see that. Single replacement, this is when you have one that's single. So this is your key thing. So do you see a single element by itself? If so, it's pretty much going to be a single replacement, especially if it kicks out. Oh, that shouldn't be in. There we go. Oh, I did it wrong. Shift arrow. There we go. So it kicked out hydrogen, replaced it, but this was single, and now I have this single hydrogen by itself. Double replacement. This is going to be one of the more complicated looking things. Nobody is single here, yet one, they like swap. If you need the notes, they are also posted in all of this. Decomposition. This is when you have the breakup or everything is breaking apart, and you can see that example there. Combustion, this is the one that can be more difficult to identify, but you will only have carbon, hydrogen, and oxygen in this one. So at the end, you'll have carbon dioxide and water. So you can just think of it as whatever we exhale. We all know that we exhale carbon dioxide, but we also exhale H2O as well. If you breathe on your hands, you can kind of feel the moisture, the fogginess from your breath. That's that water. Here's your 9 physical properties. Luster, conductivity, malleability means can it be hammered into sheets. Ductility means can it be stretched into wires. Solubility means can it be dissolved into either water or oil or something like that. The boiling points and density. Physical changes, you have these examples here. Chemical properties, there's more than this. As you can tell, it says 4, and I have 1, 2, 3, 4, 5. I already have 6 labeled, but there you go. Here's some examples of chemical change. Anytime you're burning or cooking, that is going to be automatically a chemical change. Anything that's growing, anything that has a color change, producing heat or cold. Another one is producing light. Let me add that. All of those will be definite signs of a chemical change. How do you know a chemical reaction has occurred? Well, you'll have one or more things that will turn into something else. You'll see a color change. That's almost always a chemical reaction, unless you're dealing with just like food dye. That one, you're just staining, and it's still the thing. Temperature change, light being produced, that precipitate, don't forget that precipitate is very important. Sometimes it will look cloudy, sometimes it'll look flaky, chunky, sometimes it'll look like snot. You'll have gas, change in the smell, all of those. These are the same, the 5 types of reactions. All matter has mass and volume. Explain the relationship between density and mass. So as I increase mass and I keep volume the same, density will also increase. This is a direct relationship. Density and volume, if I keep mass the same but increase my volume, is going to be inverse. And you can read the directions there, or the answers there. Compare and contrast chemical and physical changes. Provide an example. So physical change involves a change in appearance but not changing what that thing is. So ripping paper, highlighting a page in your book, mixing Kool-Aid and water, breaking pencil, all that kind of stuff. Chemical changes involves an actual change in what that substance is. So you're having the rearrangement of molecules, and there's all of your signs right there. Why do we balance chemical equations? Because the law of conservation of mass says that you cannot create nor destroy anything. Therefore, the number of each type of atom must be the same on both sides. So that's why we balance. I will post a separate video on how to balance chemical equations because I want this to be kind of quick. This is an example of a decomposition reaction because you see here I have one thing that is breaking up. Synthesis is the reverse of that. So here I have 2 things that are becoming 1. Double replacement, this one typically looks really complicated. There's nobody single on either side, so it can't be a single replacement. So I have carbon and oxygen and chlorine, and then water here, and now all of a sudden hydrogen is now with chlorine, and CO2 is by itself. That would be a double replacement. Combustion, again, carbon dioxide and water at the end, so that is your combustion. Single replacement, oh, this guy's by himself, so that means he's single, so it's going to be a single replacement. All right, all things density, yay! All things density. There's your definition of density. That you just have to memorize that. 2 ways you can increase the density. I can keep mass, or I can increase mass but keep volume the same, or do the other way around. I can decrease volume but keep mass the same. Mass and volume are the only things that affect density. If you look at your density triangle here, you have density here. Mass and volume are involved. There's your formula for that. If the mass of an object is 35 grams and it takes up this much space, remember this guy right here? This is a cubic centimeter. It's also the same thing as a milliliter, so you could literally interchange it out. I'm not going to count off for it, but I don't know if your teacher will. Depends on what they have said. All right, so my formula, all I have to do is cover up the density, and it becomes mass divided by volume. So here's my mass divided by my volume. There's my answer. That cc right there, that is a cubic centimeter. So cc and a centimeter to the third is literally the same thing, so don't even worry about it. Suppose you have a lead ball whose mass, there's mass and density, so I'm looking at the volume, so I cover up volume. Becomes mass divided by density. Put it in your calculator. There's my mass, there's my density, and there you go. What is the mass? So again, I'm covering up mass, my volume, or my, oh goodness, my formula becomes density times volume. So which one am I at? What is the mass? Okay, so then I multiply these 2 together. There's my volume, there's my density. There you go. Calculate volume, so come over here, cover up volume, it becomes mass divided by density. So boom, 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 there's my mass, there's my density. Make sure you look for the units. Mass is just going to be in grams. Volume will either be in milliliters or in cubic centimeters, okay? But density will have the complicated looking formula right there, or unit right there. Okay. The carver begins to work on a block of granite. The block has the volume of this and density of that. What is the mass? So again, come up here, cover up my mass, density times volume. There you go. Student creates a density column in class, so you'll click on this link. So here, if it's less dense, it's going to settle at the very top. If it's more dense, it's going to sink to the very bottom. So list the liquids in order from least dense to most dense, so you just list it in order from top to bottom. If a student poured mercury into the density column of the previous question, what would happen? Well, I think mercury, oh, there's mercury. Its density, typically people round it to 13.6, so it has the highest density. It will settle to the very bottom. Okay, density of point A, All I have to do is do my mass, which is over here. So here's point A, come all the way over. It's 5 divided by 5 for my volume. And I get 1 gram per milliliter. Now this is the density of water. So if it is exactly the same density as water, wherever it's placed in water, it will stay there. Now if it was lighter, so if it was less than 1, it would float. If it was higher than 1, then it would sink. That's basically what I say right here. What is the density of point B? So here's point B. I come over here and I get, I think that's 10 divided by 14. 10 divided by 14, boop, boop, boop. Oh, look, it's less than 1, so it's going to float. What's the density of point C? What is that? That's 23, something like that, 23 divided by like 24. So again, it's going to be a little less than water, so it's going to float. Use a table here to answer the following questions. An object with a mass of 24 grams and 32 milliliters was going to be what most likely substance. So I have to do my, here's my triangle right here. So looking for density, it's mass divided by volume, boom, boom. And I got this number. If I look up in the data table, the closest number I can get is wood. This is probably just a slightly different type of wood, which is why you see this slightly different type of density. So just whenever you're going through a problem like this, just go ahead and pick the one that's closest to it. What is the only object in the table that would sink in corn syrup? So here's corn syrup at 1.38. The only thing that I see that's a larger number is copper, so copper will be it. What is the mass of 100 milliliters of corn oil? So here's, we're looking for mass, so cover up mass, density times volume. So the density of corn oil, okay, it says corn oil, not syrup, so I'm using this one over here. And then I have to multiply it by 100, so 9.2 or 0.92 grams per milliliter, that's my density times my volume. There's my mass. Okay, what is the volume of 35 grams of copper? So here's copper, there's the density, and what am I looking for? Volume. So cover up volume, it's mass divided by density. There's my 35 divided by this number right here, and I should get my, oh, that's, what is it, volume? So ml. My bad, y'all, my bad. Is that right? Did I do that right? Yes. Yes, I did. Okay, there you go. Haha. So, graduated cylinder has 20 milliliters of water placed into it. So here it is on the left. Then we put an irregular shaped rock in there. And we see that the, well, this doesn't exactly show it correct, but you just look at what I have. And the rock in there now reads 30 milliliters. So, if I do my math, it was 20, now it's 30, so 30 minus 20 gives me the volume of 10 milliliters. So there it is, 30 divided minus 20 milliliters gives me that. I should highlight this, or I'll bold that. That's the answer we're looking for. Okay, what is the density of the rock? So here's my mass right here. Here's my volume right here. Okay, so 23 divided by 10 gives me this. I'll bold that for you as well. I think that's it. Yep. All right, good luck.